not forget about piecewise, but let piecewise go for now. I have some who thought they finished their test yesterday and didn't actually. Let me tell you what these blondes did. There are about 5 blondes in the room. Let me tell you what these blondes did. So it said you were supposed to graph the inequality. So they had this beautiful graph. They had a graph like this. They had a line. Some of them even thought through the solid and dotted part. And then that's all they had. What did they not do? They didn't shade. They didn't either shade above or below. They didn't shade. I had seriously, there were about 5 people in here who did not shade at all. And I don't know why they did that. I thought it was kind of funny, kind of sad. I might have wanted to cry a little bit.
You still warrior rule?
It's an O. It's just ugly. It's ugly. Okay, so let's look at your math workshop for today. We've got 3 of them. You've got a new giant packet of notes. The good news is that giant packet is only 2 lessons from Chapter 3. That's how long we're going to be in Chapter 3. In fact, we're in Chapter 3 for so long that Seth's next test is only going to have 1 section on it. We're going to take a test when we finally finish 3.1. There's that much stuff inside this 1 section that we're going to take a test when we finally finish this 1 section. So the test for 3.1 is going to be one day next week. The checkpoint, there is a checkpoint for 3.1, and it's going to be on Friday. It won't take you long. And in fact, again, I'm not trying to be ugly, but I did have Will last year, so I can pick on Will, especially when he does this when I'm talking to him. I know I taught Will how to solve by substitution, elimination, and graphing. So if he struggles today, that's on him, because your algebra teacher taught you, so I need you to get together. Okay, I need table 3 to add a point, and table 4 to add a point. And table 1 can add a point. Okay. I need those groups to add a point. Let's get looking at these 3 math workshops we need to handle today, and then we'll get through our notes quickly. That way those who need to finish their test can finish their tests. Okay, so number 3, it's got 3 terms. Is there a GCF I can pull out?
At this time, all brass players for the band need to go to the band room at this time for the brass players clinic. At this time, all band members for the brass players clinic go to the band room. Thank you.
So I pull out a 2A. What am I left with? 13B, and then what? And then what? Eduardo, you can have a point for that. Okay, and then our question from here. So we had this whole discussion. Bye, Patrick. Check YouTube. We had this whole discussion about from here we might be able to keep factoring. That's not the case for this one. But from now on, we got to think through it. Can we keep going? Yes. And the answer is no on this one. But in some of the future, the answer will be yes. Yes, yes. Okay, are there any questions about 3? Let's go ahead and do 6 since it's right underneath. Let's go ahead and do 6 since it's right underneath. Okay, on number 6, what's something I can pull out of everybody? I think 5, but surely there's something bigger than 5. Can you pull out 25? 35? You can pull out a 30. 35 goes into 75? 35 times 2 is 70, so that can't be it. Can't be 35. I thought 25, but 105 isn't divisible by 25, is it? No. So the highest I can do is 5. 5 is the best. Thank you, Mackenzie. You can have a point. 5 is as high as we can get. And then I already closed parentheses. The biggest common factor I could find was 5. 25 doesn't go into 105. 35 doesn't go into 75. 10 doesn't go into 75 evenly. The best I could do was 5, sadly enough. And I couldn't factor out an N. Why?
Because it's...
it wasn't in the last term, and the person I heard say that was Miss Brister. So I guess we could give Miss Brister's group a point, but we won't. Okay, moving on. 105 divided by 5 is what? Can someone help me factor from here and get your group the point? 21 n cubed, and then what? 35 n squared, and then what? 15 n, and then what? 25. And your group can have a point for that.
Just one. He did multiple balls.
He did a good job. We're only going to give him one. Okay, so again, everybody didn't have an n, so we couldn't factor out an n. We wanted to do something higher than 5, but we couldn't. Thankfully, Don Terrius can use his calculator, and he helped us reduce all this. Are there any questions about number 6? Okay, I get it's homecoming week, and I know you're a little bit distracted, and I really kind of get it. But at the same time, we're still going to do math, and eventually you're still going to take a test, so you've got to get it together. Okay, number 4. Is there something we could do? How many terms do we count?
4.
And what did we say we should do with 4?
Put them in parentheses.
We should see if there's a GCF first, and then we should do grouping. Yes, thank you, Seth, and you can have a point for that. Here. Did it have 4? It did. So could I keep going from there and do grouping? Yes, I should. So Miss Compton's not done, and your group gets a point for pointing that out for me, because I was having a blind moment. Okay, go back to 6. We weren't done. We weren't.
Oh, yeah, we saw one.
There were 4 terms now that we pulled out that 5. So I need to do grouping where I put these 2 together and these 2 together. So I'm still going to leave that 5 on the far, far outside. In fact, I'm going to put a giant bracket. That way I don't get that 5 mixed up with nobody. What can I factor out of, more points available, what can I factor out of 21 n cubed plus 35 n squared? 7 what? And what would you be left with? Perfect. So that's from that first term. This one led to 7n squared plus 3n plus 5. Now, as for that negative 15n minus 25, what should we factor out of it? Okay, yes, we should factor out a 5, but shouldn't it be a negative 5? Okay, if we factor out a negative 5, what are you left with? It's not going to be minus. Again, it's going to be plus 5. Because negative 5 times positive 5 is negative 25. And Kelsey's group gets another point. My gosh, they're on fire today. Okay, I'm happy right here. Why am I happy?
Because we're...
Why am I happy? Yes, because these 2 match. I'm happy. So I know I'm going to have the 5 on the very outside, but what are my 2 different binomials going to be? One's going to be 3n plus 5. What's the other one going to be? 7n squared minus 5. Kelsey, your group has another point. That's a minus 5, by the way. Pardon how. Okay, that one was a little challenging. It required a little more time. And I'm really glad they caught me on it, because otherwise I would have left it be and there was much more to do. Kelsey, what are y'all at? How many points? Go to 5. Okay, let's go to number 4. 21k cubed minus 84k squared plus 15k minus 60. I got one table that's not earned a single point today. How sad is that? Okay, it really is. Let's look at this one. I'm trying to see if a number goes into all these things. I have a number in mind. There is a number that goes in all 4 terms.
Oh,
21 would not go into 15.
oh.
But there's a GCF first before I do grouping. There is a GCF I can pull out. It is 3. It is 3. It was 3, Seth. You can have a point. Okay, so if you pull out a 3, you're left with 7k cubed. What's 84 divided by 3? 28k squared plus 5k minus 20. So we almost missed it. There was a GCF we could pull out first. Now we do have 1, 2, 3, 4 terms, so we can do grouping. So I'm wondering if there's something that I can pull out of 7k squared minus 28k squared. What goes into both of these? 7 what, ma'am? 7k squared, and your group gets a point. You would be left with k and then minus 4. So that's what I got from that first term. And then from that second term, what would you be left with if you factored out a 5? What would you be left with?
4.
You'd be left with, again, k minus 4.
And
And then I'm happy because both of them say k minus 4. So if you can read the final answer to me, your group will get another point.
They're the same, so it would be 7k to, 7k squared, k minus 4.
What? Keep going, Paige. Okay, and then what's the other one? Good, and your group gets another point. And Seth, you're going to get your group last 1 point, but you already got a couple. Let them get this one.
No.
Yes. I know. You're going to get some more. I'm confident. You're going to get to a 5 today. I'm confident. Confident. You're already at 5?
Yeah, I'm trying to get 10 more.
Oh, good. Good. Okay, you got a new note packet. Pull it out. Before you put your math workshop away, especially those at, I'm going to call you out, table 5 that were distracted today, you know who you were. Guess what? Guess what time it is? It's getting to the end of the 9 weeks. Not today. Not today. Next week. We won't do Monday because I hate Monday things. Next Tuesday. Alonde has a math workshop test. Does Alonde get to use his math workshops on his math workshop test?
Yes.
No, he does not. He has to have actually understood what we've been doing. It is like a for real test. So it's going to have some like this with grouping. It's going to have some like this with simplifying radicals. And we'll talk more Monday about exactly which math workshops maybe you should study. I can be that nice. But surely to goodness, Mackenzie's kept up with all her math workshop pages. And she can study those. And I'm telling her super far in advance, your math workshop test is next Tuesday. So if you've been zoning out, God bless you, you're going to do terrible on this because you do not get your math workshops. You've got to actually be paying attention with your brain. Okay, you got a new packet. Let's look at it. We're only doing the front 2 pages. The new packet. Let's go to page 1 of the new packet. We're only doing page 1 and page 2 today. Okay, today is supposed to be an easy day. So we're starting a chapter that the first section is on systems of equations. And your math teacher taught you how to do it by substitution, by graphing, and by elimination. Now, you would think the easiest would be graphing, and that's the way we're going to talk about today. But sadly, it depends on the problem, because the way this problem is set up and the form that it's in, it's not really set up to graph. So it's really going to be annoying to put it in graphing form and then graph it. You're going to learn there's a better, easier way. And eventually on the test, Braxton gets some choices, but then on some problems it'll say specifically Braxton, well, it won't say his name, but it'll say solve by graphing, solve by substitution. So you have to understand all 3. Okay, so the hardest part I think today is the new vocab. To be honest, I didn't realize this was a thing, but I've seen the chapter 3 test and this is a thing, so if I were you, I would put a star next to that vocab because I know it's specifically referenced with a vocab section on the next test. So it will be on the test, which will be next week. And if I could get my math done fast enough, good Lord, fast enough, I would say the test is next Tuesday. Okay, so the first link is system of equations. Your group's about to lose point 1. A system of equations is 2 or more equations with the same variables. So for instance, look at number 1. They have x's and they have y's. X and y. They have to have the same variables. Systems of equations can be classified by the number of solutions. How many solutions could a system of equations have? A system is consistent. Can't spell today. Consistent. It's consistent. A system is consistent if it has at least one, go down a point, solution. So consistent goes with 1. And then what word would go with no solutions? What's the opposite of consistent?
Non-consistent.
So we're going to have inconsistent. And you, for group, gets a point. So if you have one solution, you're called consistent. If you have no solutions, you're called inconsistent. Okay, well, if you're consistent, meaning you do have a solution, there are technically more than just the one option. The system can be, and our words are independent. Guess on the second word? And your group gets a point, Gracie? So our system, if it has a solution, it's consistent, and then it can be independent or dependent. And that depends upon if it has exactly one, it is independent. And if it has an infinite number, it is dependent. I don't know about you, but paragraphs don't really work for me. So I have to make myself a list. That's what I have on my little post-it to keep me straight. So consistent is one solution. I don't spell out solution. I just put SLT in. Inconsistent, no solution, so 0 solutions. I just put a mark through it so no one would think that was the letter O. Independent and dependent. Independent is exactly one. And dependent is when you have infinitely many solutions. So if you just want to put the infinity sign, that's fine. So we either have a solution or we don't. And then if we do have a solution, we might have just that one and it's unique. That's why it's independent. Or it might work for every point imaginable, which is why it would be infinitely many. Okay, so for the first free point, I feel like this one's a really nice free point from the notes. I see number 1 is written in, these two equations are written in what form? What form are these equations in? They're in standard, Braxton, you're going to miss a point. They're in standard form. Is it easy to graph in standard form?
Wait, say that again.
Is it easy to graph in standard form? No, which is why Seth was saying we need to get y equals mx plus b or something. I thought it was him. So that's why someone was saying something like that. We can't graph this, so we've got to rearrange both equations. So if I subtracted x from both sides, I would have 2y equals negative x plus 6. If I divided by 2, I would have y equals negative 1/2 x plus 3. Are there any questions about that top equation? Okay, well then with the bottom equation, if I subtracted 2x, I would have y equals negative 2x plus 9. Are there any questions about that bottom equation? So what we're looking to see is, do they cross? Because if they cross, if the two lines cross, that's where that solution is going to be. So in fact, let's draw us a picture. So let's see, exactly one solution, if this is my coordinate plane, exactly one solution is going to look like two lines crossing. So a line that crosses and X marks the spot. That point is where that one solution occurs. What would no solution look like?
They don't cross.
They don't cross, so what kind of lines would they be then? They're parallel. So Kelsey and Allie, you can have a point, and Seth, I believe I heard you too. They're parallel. No solution. Okay, but then we get to the fun one. So we either have, because we were discussing one solution, no solution, and then we also have that case of infinitely many solutions. What would infinitely many look like? What would it look like? No, that's a nice guess. What would that look like? Infinitely many.
That means like they're always crossing.
They're the exact same line. And you're missing another point. They're the exact same line. So this one line is both of them. It's both graphs. So if some miracle, when we graph, we get the same line and they're living on top of each other because they're the same person, it's infinitely many. Okay, I can already tell from our equations that this is not going to be an infinitely many day. They don't have the same intercepts. They don't have the same slopes. It's not going to be an infinitely many. So either our answer for this problem is going to be the one solution or the no solution. And then back to, sadly enough, you and I have got to use the correct vocab. One solution is not good enough. You got to say consistent. No solution is not good enough. You got to say inconsistent.
What about independent?
So you would say consistent and independent if it had exactly one. Consistent and dependent if it had infinitely many. So, in fact, if you want to add the vocab, now here's a good point. If we want to add the vocab over here, we sure could. One solution would be consistent and independent. No solution would be inconsistent. And then infinitely many is consistent because it does have a solution, but it's dependent because that solution is not a unique solution. Okay, I know that's a lot of vocab and information all at once, but if we practice a couple, I swear it's going to be fine. So, for instance, we got to graph this green line, negative 2x plus 9. So I got to go up to 9. 1, 2, 3, 4, 5, 6, 7, 8. Of course, 9's off the graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course it is. So we just have to kind of guess. Our slope is negative, so my line needs to lean to the left. So down 2 over 1, down 2 right 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 1. So there is my green line. Maybe I can connect the dots today. Are there any questions about graphing the green line? Well, we also have to graph that gray line. It's negative 1/2 x plus 3, so we got to go up to 3 for our intercept. 1, 2, 3. Our slope is negative 1/2, so I'm going to go down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. Down 1 to the right. Down 1 to the right 2. Up 1 left 2. But I already know the answer. I'm just graphing because I like to graph.
They cross.
They did cross, so what does that mean our answer is?
They're consistent and independent.
They are. So I'm going to say consistent, and is it dependent or independent?
Independent.
Independent because it's that one unique solution. And Natalie, I heard you the loudest. You can have the point. And in fact, we could pinpoint that exact solution. Exactly at what point were they crossing at? Was it you again, Kelsey? Okay, 4-1. So our solution is at 4-1. That's where they cross. That's what the solution is. But using the right vocab terms, like the directions suggest, consistent and independent. Okay, so number 2 looks a little better. It looks like reverse standard form. I need to rearrange this equation. I add x to both sides. I get y equals x plus 5. I need to rearrange this equation as well. I add 2x to both sides. I have 2y equals 2x plus 8. Am I done?
No, you gotta divide 2.
Now you get another point. Divide both sides by 2. You get y equals x plus 4. So I need to graph the pink line, y equals x plus 5, and the blue line, y equals x plus 4. But I already know the answer. I already know the answer. Does anyone else already know the answer without actually having to graph from here?
Yes. No.
They're parallel.
I know they're going to be parallel. Did you tell her that? Or she knew? You can have 2 points for that.
Okay.
How does she know they're parallel?
Because they're not the
The slope's the same, and they have different intercepts. She's a genius. So from here, I already know what words to use. They're parallel, so it's going to be no solution, which we decided that vocab term we're supposed to use is not no solution, Miss Compton. Come on. We're supposed to use the vocab term inconsistent. Now, does it help Hunter if, to prove it to himself? Would it help if he went to plus 5 2, 3, 4, 5. And actually went up 1 over 1. Yeah. Maybe he likes graphing, like Miss Compton. If he wants to do that, he graphed the pink, yay. And now he wants to graph the blue. Yay. He can. But seriously, if Hunter realizes what it is before he graphs, it does not hurt my feelings if he moves on from here. I didn't have to graph because I recognized they had the same slope, different intercepts, so they were going to be parallel anyway. Okay, any questions about that one?
On the test, did you take off?
No, I'm not going to take off if you don't graph, if you got this part right and you're confident with it.
Like, if we put no solution.
No. No, I'm not going to, no. But I'm going to try to be good and use the vocab that the book uses, because apparently it is.
Sure.
Okay, flip to the next page, if you can. We've only got 2 left, and I'm done talking. In fact, I think I'm only going to do one of them, and then we'll save the other for tomorrow, because I need to let you have time on that test. Number 3, I've got to rearrange that equation. I'm going to subtract 3x first, and move it so 3x is on the other side. And then, set this right, I divide by 2. So I'll have y equals negative 3/2 x plus 6. Are there any questions about the blue? Well then, same thing down here. If I subtract x from both sides, I'll have negative 2y equals negative x plus 4. I divide by negative 2. I end up with y equals negative 1 over negative 2 is positive 1/2. Positive 4 over negative 2 is negative 2. I don't immediately know the answer from here, except I do. I don't know what point they meet at, but I'm sure they meet at a point because one has a positive slope and one has a negative slope. They don't have the same slope, so they're not going to be parallel. They don't have the same slope and intercept, so they're not going to be infinitely many. So I know there's a solution, but I have to graph to figure out where that solution is. Okay, so if I go up to 6, 1, 2, 3, 4, 5, 6, down 3, right 2, down 3, right 2, down 3, right 2, down 3, right 2. And I do my best to connect those dots. For the green line, I go down to negative 2. I put my intercepts. I count up 1 and to the right 2, up 1 and to the right 2, up 1 to the right 2. And I keep graphing, but at this point, you should have realized, hey, I know the answer.
They cross.
They cross, and I did not do a good job down there. It didn't matter, because I got the solution. Where did they cross at? I heard 4. It's 4, 0. Yes, now you get the point. They crossed at 4, 0. And what vocab terms did I use?
Consistent and dependent.
It sounds like you got it. We'll do number 4 tomorrow. There is a workbook. There are 3 problems from the workbook I wanted you to try. I won't check it tomorrow since some people are going to work on their texts now. But the sooner you get it done, the sooner I can write it down, the sooner we can move on. So it would be smart to have it done by tomorrow. Otherwise, I don't care if you pack up all your things. Look, I gave you the full 10 minutes this time. I have the following tests that need to finish. Cameron, Tyree, Patrick, Alex, Alonde, Rontarius. Yeah, and we're gonna, let me pass it out and then I'll need yours. Patrick, Alex, Dave, Rontarius, Tyree. Will you hit Rontarius and Tyree? Okay, will you give Alonde his? Patrick's on here.
Who took both?
Here. Okay. I have a few tests that thought they were done again, and they're not. They need to look at that back page on graphing inequality. Will, Eduardo, Addison, Zach.
That's the one we got to shave.
Yeah, look at the back. I need you to fix the back too, so I can get your point back. You're not getting any points back anywhere else. I mean, on the very back page, fix it. The very back page. Fix the very back page. That's not you. That's you. Will, you and Addison come fix the very back page. One chance, or else I have to take the points off as it was. Sorry. Run.
I'm supposed to say these two.